Hey guys, it's Miss Johnson and I'm here to bring you our fourth notes video for Unit 4. Unit 4 is all on factoring, which we've said that word a whole lot throughout this unit. And today we're going to be factoring special cases. So that's our learning target for today. The first special case that we're going to talk about is something called the difference of two squares. Difference of two squares is a form that looks like this. It's a binomial. It has only two terms. So I have ax squared minus c. And what happens here is that a, the first term and the last term, the two terms, I should just say the two terms, are both perfect squares. Both is important, perfect squares. And the other thing about this is that there's subtraction in the middle. In between them. Okay, so what that means is when we're subtracting two perfect squares, the b term, it can be called 0x because that 0x is gone. Our factored form is going to be the plus and minus pattern where you have like an m and an n and an m and an n. You get the same two terms. One is positive, one is negative. So you'd have the same two terms in both factors. It's just one positive, one negative. So let's talk about the steps for that. Check for a GCF. Only take it out if it makes perfect squares. So if we have a GCF, but we already have perfect squares, you can leave it in. And then we're going to set up this factored form of just these two binomials. We'll take the square root of each term, put the square root of the first term in each parentheses, put the square root of the second term in each parentheses. So there it is. We'll take a minute to write those steps down and then we'll get going on some examples. When I take a look at number 1, I have n squared minus 25. N squared minus 25. N squared is a perfect square. It's a variable multiplied by itself, no other coefficient out front. So a variable multiplied itself is a perfect square. 25 is a perfect square, we all know that. So, and there's subtraction in the middle. That's an important thing. It has to be subtracted in the middle. So I'm just going to set up my pattern here. I know I'm going to have one that's adding and one that's subtracting. And by the way, you could have put the subtraction first and the adding second. It makes no difference. And then I take the square root. The square root of n squared is just n. This square root symbol cancels that power of 2. And then over here, the square root of 25 is 5. So I have an n plus 5 and an n minus 5. Now, I just want to take a brief second to show you, this is really just a shortcut for factoring n squared plus 0n minus 25. If I put in that 0n term like we talked about, the term that's been dropped out, this is what would happen. 1 times negative 25 is negative 25. The middle term I want 0. So I would have a negative 5 and a positive 5, which gives me n squared minus 5n plus 5n minus 25. And I group and group, and I can take out an n here, leaving me with n minus 5. I can take out a 5 there, leaving me with n minus 5. And I get n plus 5 and minus 5 behind. Same answer. It's just that by recognizing that these are perfect squares that are being subtracted, I have made my life a lot easier for as far as factoring goes. You save yourself all of these steps. Okay, now if you don't recognize that these are perfect squares to use the shortcut, that's fine. This will work for you every single time. Put the 0n in the middle, set up your x, factor by grouping. That will work for you every time. So don't let this part confuse you if it's something that you're not comfortable with. Okay, so let's take a look at number 2. 36x squared minus 49y squared. 36 is a perfect square, 6 times 6. 49 is a perfect square, 7 times 7. X squared is a perfect square, x times x. Y squared is a perfect square, y times y. So, and I have subtraction in the middle. So I know I have a difference of two perfect squares. I'm going to have positive in the first one, negative in the second, or a plus sign in the first one, minus sign in the second, and those could be reversed. It doesn't matter. Just one needs to be plus, one needs to be minus. And then I take the square root. Square root of 36 is 6. Square root of x squared is x. So I have 6x in the first spot in both of them. And then the square root of 49 is 7, and square root of y squared is y. Now, it is important that the square root of the 36 stay in front of both terms, and the square root of the 49 stay in the back of both terms. So that's my factored form, and I'm ready to go. If you have a hard time seeing if this is true or not, go ahead and FOIL it back. Remember in Unit 3 when we talked about FOILing? Multiply it back and see if you get back to your original result. If you put the multiplication back together, because remember that's what factoring is undoing that multiplication. If we put the multiplication back together, we should get back to that original factored form. All right, let's talk about number 3. So number 3, I have 48a to the third minus 12a. Now, as I look at them, they are not perfect squares. A to the third is a times a times a. A squared is a perfect square, but throw that third a in there, and now you don't have that. And when I have a to the first power, that's not a perfect square either. 48 is not a perfect square, 12 is not a perfect square. However, I can take out a GCF from these. And when I take out a GCF, let's see what happens. If I look at the GCF of, gosh, 12, I can take out a 12 here. If I divide by 12, I can also take out an A. Take a look at what I get. I have 12a out front. That leaves me with 4a squared minus 1. Now, 4 is a perfect square, 1 is a perfect square, a squared is a perfect square, subtraction in the middle. Now I have my difference of two squares pattern. So this 12a is just going to be on front of the factored form, and then I have the plus and minus pattern, plus, minus, and take the square root. Square root of 4 is 2, square root of a is a, or square root of a squared is a. Take the square root of 1, and it's just 1. So 2a plus 1, 2a minus 1, with that 12a out front. That's my factored form. Let's try number 4. 9x to the third minus 4x. Now that I can take out an x. I have a GCF of x that can be divided out. The 9 and the 4, hopefully we all recognize that 9 and 4 are perfect squares. So those I'm just going to leave alone. So that leaves me with 9x squared minus 4. Now that is perfect square, subtraction in the middle. So I'm going to set up my pattern. I know I have that x GCF out front. The square root of 9 is 3, and the square root of x squared is just x. Square root of 4 is 2. So I have 3x plus 2, 3x minus 2, x out front from the GCF, and that's my factored form. Okay, a couple more like this on the top of the back page. 64 g squared minus h squared. Those are both perfect squares. 64 is perfect square, 1 is a perfect square. Our variables are both raised to the second power. So all I need to do here is set up my factor pattern. When I take the square root of 64, I get 8. When I take the square root of g squared, I get g. From the h, square root of 1h squared is just h. So I have 8g plus h and 8g minus h. There it is. Now, when I look at number 6, I have negative 4y to the third plus 9y. Now, there's a couple things going on here. I don't have subtraction in the middle, but I do have this term that's positive and that term that's negative. So this can really be written as 9y minus 4y to the third. Now, I do have a positive in front and subtraction in the middle. So then the second problem that I notice is the fact that I have a y here and a y to the third. Those are not perfect squares. But if I take out one of the y's and put it out front, I'm left with 9 minus 4y squared. Now, 9's a perfect square, 4's a perfect square, y squared's a perfect square, subtraction in the middle. Now I can use my pattern. So it was just a matter of rearranging things, but I can switch the order of addition. Addition is commutative. And I can divide out a GCF because I didn't change the question when I took the same term out of both parts. So I have the y out front, which was the original GCF. I have the square root of 9, which is 3, and the square root of 4y squared, which is negative 2y. And then I have 3 plus 2y. I switched up my pattern here, but that's okay. I can write the minus 1 in front and the plus 1 in the back because multiplication can go in any order. All right, so that is our difference of two squares. Now we also have something that's called a perfect square trinomial. So it's a trinomial that has perfect square factors in the front and the back. So what happens here when we factor this is we end up with two factored terms that are the same. They're going to be identical. I had to get an x minus 4 and an x minus 4, for example. That just means I can write it as a binomial squared. This is called a binomial squared. And we saw some of these back in Unit 3 as well, when we talked about how you'd have this binomial squared, you need to multiply it by itself and FOIL. Well, now we're just undoing that. Okay, so let's do some examples. I have n squared minus 24n plus 144. Now I'm going to factor the same way I factored before. I'm still going to set up my factor x, look for a GCF if I have one, set up my factor x. I'd have a 144 on the top and the negative 24 on the bottom. The only way I can get that is when I have a negative 12 and negative 12. This is where you can start to see that they're going to be perfect square trinomials because you have the same two factors. So I have n squared minus 12n minus another 12n plus 144. Group them, and I divide out an n. So I have n and then n minus 12. Here I divide out a negative 12. The reason I'm making it negative is because I want this to go back to positive n. Right now it's a negative. I need to divide out a negative so that it's positive. So I'm going to divide out a negative 12, leaving me with positive n and minus 12. So I have n minus 12 times n minus 12. But again, if this were a multiple choice test, you would see that as n minus 12 quantity squared. Binomial times itself, quantity squared. Let's take a look at number 8. In number 8, no GCF to take out, so I'm just going to set up my factor x here. The top number, 9 times 4, gives me 36. Middle number is negative 12. That's going to be a negative 6 and negative 6. Notice, by the way, that 9 and 4 are perfect squares. 144 was a perfect square. 1 is technically a perfect square. That's not a coincidence. When the first and the last term are perfect squares, as long as it fits this factor pattern, that's what gets you the perfect square trinomial. So, split the middle. I have 9y squared minus 6y minus 6y plus 4. I then group and group. From the first one, I can take out a 3y, leaving me with 3y minus 2. From the second one, I can take out a negative 2. And again, the reason I'm making it a negative 2 is because I want my 3y to be positive. Right now, my negative is with the 6, so I've got to take out a negative 2. When I take out a negative 2, that leaves me with positive 3y minus 2. Same, 3y minus 2. Outsides, 3y minus 2. There's my perfect square trinomial. So I have 3y minus 2 quantity squared, and there it is. Okay, a couple more examples. In number 9, I have 18y squared minus 48y plus 32. These are not perfect squares. 18 and 32 are not perfect squares, but I recognize that all three of these can be divided by 2. If I pull a GCF of 2 out, that leaves me with 9y squared minus 24y plus 16. And now, perfect square, now I'm looking at a perfect square trinomial. So, set up your factor x. 9 times 16 gives me 144. And then I want a negative 24 for my sum. Well, 144 is 12 and 12, but they both need to be negative because I want a negative 24 sum. So here we go. Take out your middle. Remember GCF, bring it down to the bottom. That's a 9y squared minus 12y minus another 12y plus the original 16. Be careful not to put that negative 24 in that spot. It's a common mistake. Group those together. From the first one, I can take out a 3 and a y, and that leaves me with 3y minus 4. From the second one, I want to take out a negative 4, which leaves me with positive 3y minus 4. So I have 3y minus 4 and 3y minus 4 with that original 2 out front. Now that's a perfectly fine way to write your answer. I would not have marked that wrong. Or you can write that 2 out front and then put 3y minus 4 in parentheses squared. And that is how you would see it if this were something like the ACT or MCA. Okay, last question. 50g squared plus 40g plus 8. So first thing I recognize is that I have a GCF of 2. So I'm going to take that GCF out and see what that gives me. So I have a 2 out front, 25g squared plus 20g plus 4. Now I recognize that I have a perfect square trinomial. Perfect square term, perfect square term. Set up your factor x. 25 times 4 is 100. Middle term is positive 20. That's going to be a positive 10 and positive 10. So right away, since I'm getting the same things inside, I know I'm going to end up with the same two factors. So 2 comes down to the bottom. 25g squared plus 10g plus 10g plus 4. And yes, I threw x's on those just out of habit, but they're actually supposed to be g's. That's okay. So then I group and I group. From the first group, I can take out a 5 and a g. So 5g leaves me with 5g plus 2. Second group, I can take out a 2, leaving me with 5g plus 2. So I have 5g plus 2 and 5g plus 2. So I have 2 times 5g plus 2 quantity squared. Notice that this 2 GCF and the 2 GCF that was over here is outside of the parentheses, not being squared. That's an important thing. There's only one factor of 2, even though there's 2 factors of this 5g plus 2. Okay, that's going to take us to the end of our notes for today. So thanks for listening. Don't forget to check off your notes sheet with Ms. Johnson. Come get your practice, and I will see you all later.